today. So can you please start by introduce yourself a little bit about yourself and also your role at SemiAnalysis?
Sure. So I am the chief analyst of SemiAnalysis, and SemiAnalysis is a market and semiconductor supply chain research firm. We and consulting, and we focus on from the manufacturing process technology all the way through to design IP and ASICs, and strategy as well. We're all surrounding the semiconductor industry.
Oh, very cool, very cool. So today we are going to discuss about the development of the ASIC projects in large technology companies, and also the driven factor behind that massive ASIC investment. And in fact, so Dylan, so you come on our radar screen is when you wrote about a very famous Google Argos article. And why did that technology intrigue you? And can you give us a little bit brief about your thoughts about that or your findings?
Sure. So Google's created a few pieces of custom silicon, ranging from the tensor processing unit for AI, which is very famous and everyone knows. But one of the lesser known pieces of silicon that they've sort of created for their own in-house needs is Argos. It's a completely new kind of application specific circuit, right? It's a video coding unit, or a video processing unit, VPU, VCU. And the main idea behind it is that Google has very unique needs, or at least they have a unique scale with regards to how much video they ingest and then serve, or photos they ingest and serve. And so they'll get video in all sorts of formats and resolutions from their consumers, uploaded to a number of their IPs like YouTube, Google Photos, Google Drive. And they have to stream it back out to these users. But you don't just store the raw file and then send the raw file, right? Because what if someone needs to, someone wants the highest resolution and someone else wants, they have a limited bandwidth, or limited data per cycle. So they have to store it in many different formats. And at the same time, storing all this data across, the billions of hours of YouTube that are out there would be incredibly expensive, on a cost basis, right? Of just storage, of streaming, right? Data streaming is expensive, networking is expensive, storage is expensive. So they created a new ASIC called the VCU Argos. And the whole purpose is to encode video, right? And before they encoded video as well, but they did it with x86 Intel CPUs, right? They did it with Intel Skylake, and before that, prior generations of Intel CPUs. The problem with this is that the CPUs are much less efficient, especially when you start moving to more advanced video codecs, for example, VP9 and AV1. That save you on storage, save you on bandwidth, but involve a lot more processing to encode the video. And so these CPUs start to hang up in terms of performance. You start needing so many more CPUs. It's actually a delta of millions of CPUs. Wow. that Google needs, if they were to encode everything with just CPUs, which is incredibly costly.
Yeah. And also, I think there's also one element about the innovation products, right? So it's not only regarding cost, it's also regarding how they can serve the customers with the new experience, new features, like of course the Stadia already shutting down, but without the VC, I believe they couldn't even start. That is a given. Yeah. So Dylan, yeah. So I think you also gathered many very interesting data in your article talking about different solutions and also the cost per different solution, right? So could you give us a little more insights about those findings? So there's a very interesting talk about, right, the software is eating the world, but in fact, I think for the video industry, it's not only eating the world, eating the CPU too, right? So maybe you can talk a little more about that part.
Sure. So there's some interesting data that sort of we could point to with regards to why the CPU is being eaten and what needs to be done, right? So when you look at the throughput figures of a Google Argos VCU, right, versus a Skylake CPU, the CPU is 5 times slower, and it uses way more power to encode VP9, which is Google's video codec for the entirety of YouTube, and it has been for many years. And it's significant. It uses significantly more power. So using their quoted performance, right? Even if you assume Google servers are used 100% always, right? Which is very, very hard to do. No one gets 100% utilization. All the YouTube, Google Photos, Google Drive, video. If you just assume it's all 1080p 30 FPS and you do H.264, which is a decade old or even older encoding technology, that's 900,000 Skylake CPUs. That's incredibly costly. Now, if you switch to VP9, which saves you a lot of capacity and bandwidth when you're streaming video, then all of a sudden you're at 4.2 million Skylake CPUs. So this is getting when you imagine each Skylake server CPU, each Skylake server was $15, $20, $30, $40,000. It starts to add up to billions of dollars. And then and that's just with 1080p 30 FPS, right? Most people's phones can shoot 4K 60 FPS, or a lot of people record at higher resolutions. So if you use 4K 60 FPS as the assumption, then H.264 is 7.2 million CPUs, and VP9 is 33.4 million CPUs, right? So this is getting to the point where it's just literally impossible to get that many, right? If you think about it, there's about in 2022 there's about 30 million CPUs shipped total. So we're talking about the entire capacity of the whole world just for YouTube encoding, right? Not even serving the video, not even like any of the search or algorithms or comments or likes or any of that stuff. No, just encoding the video would require the entire world's capacity of CPUs. So the situation is very dire, and that's why Google made their VCU. And as we look forward, right, capacity of video is just continuing to grow. In fact, more people are uploading video than ever before with the advent of short form video content, in the form of TikTok and Instagram Reels and YouTube Shorts and so on, right? Or Twitch, right? More people are streaming, right? With this stuff, rising in popularity, being able to store it becomes even more costly. You need to get that file size down, and so the industry's rallied around AV1, which is a new video encoding software or codec, and it dramatically reduces the size and capacity of files while maintaining the video quality. But the issue is that it's so costly to compute. I mentioned these numbers of 7 million and 33 million. These numbers would more than double, right? If I think about YouTube with AV1, it's hard to estimate because CPUs are quite efficient, but even with the most current generation CPUs, right, not Skylake, which is really old, but the most current generation CPUs, it would still be something on the order of 70 million servers. So that's an incredible amount of compute that's not even possible for the world to make. So if YouTube wants to move to VP9, which they've already done with their Argos, or if they want to move to AV1 with their second generation version of that chip, they have to use their in-house expertise to design custom silicon for this purpose.
Yeah, that's a truly amazing number and not feasible at all. So they have to find new solutions. That in fact, that's also what we hear every day from our customers. So they tell us if without the new solution, they couldn't even run their business they want to or they need to, right? So it's literally the economically not possible. In fact, when talk about the Google, the YouTube, when we talk about the AV1 or the new codec, we know there's a famous quoting that they have 500 hours video uploading per minute for the YouTube, right? That's a few years ago. But that only talk about the new ingest videos. They didn't talk about how many archived videos they have. Once they have the new codec involved, they need to have every video re-encoded again, right? Think about that. They themselves they couldn't even count that number. Right? That's just
That's an important point, right? The numbers I was saying is just what's uploaded today, right? What's uploaded each year, but you know, we have 15 years of history, right? You're going to want to save that video and crunch down on that storage so you don't have to buy more storage, because storage isn't improving really in cost much. So, you know, that's a great point.
Yeah, exactly. And since you also mentioned the Twitch before, so last September you were highly critical of Twitch cutting their revenue split to producers compared to the YouTube, right? So why is that? Could you provide more insights?
Sure. Last September, you know, Twitch made a very sort of controversial move, if you will, by changing their revenue splits with their partners. So this was in, you know, I think late September or October. They cut the revenue split from 70/30 to 50/50, which is significantly less than YouTube, which has a 70/30 split. Um, and you know, these cuts targeted, you know, their larger content creators, because Twitch was, you know, in a bad place, right? They have all this video uploaded to them, and they have to distribute it. But they couldn't make, you know, enough money to support it. Why? Because their infrastructure was behind where Google's is. You know, Google has a superior infrastructure due to their use of their Argos chip, which enables them to give content creators 70% of the revenue that they generate rather than 50%. And at the same time, YouTube also provides higher quality video, higher resolutions, higher bit rates, HDR, those sorts of things, even on live video, which Twitch cannot. Twitch does not offer that because they can't with their CPU architecture. Because, you know, you know, Twitch needs to move to an ASIC, but they don't have those in-house design capabilities. Whereas YouTube has been, you know, and Google have been designing their own ASICs for a handful of years for this problem. And so many of Twitch has had some really big impacts. Like, sure, they were able to cut the revenue split from 70/30 to 50/50, but some of their biggest content creators moved to YouTube. They switched to YouTube streaming, and they brought, you know, not everyone, not all of their viewers switched over, but many of their viewers did switch over to YouTube Live. And so you know, Amazon and Twitch, you know, they faced a big financial problem, right? They either had to, you know, go down this route of cutting, you know, the revenue splits, or they lost some streamers. So either way, they were in a lose-lose situation because of their inferior you know, lack of ASICs and their inferior hardware and server infrastructure.
Yeah, that's true. That's true. Yeah. Yeah, and also think about if they want to, on that base, to create more unique or new experience to the customers, that would be very challenging with current infrastructure. Right? Yeah, more interactive contents or more higher quality videos or new formats of the service. Right? That's really challenging. Yeah, yeah. So yeah, so we mainly talk about the x86 and also the ASIC right now, but in fact, in the industry, there's still some other solutions like GPU or FPGA. We call it solution, but really, do you have any other insights about the other hardware approach that we should discuss here?
Sure. So there's some other approaches in hardware out there in the industry. For example, you know, there's some Xilinx FPGAs that are, you know, maybe target this market a little bit. There's some, you know, Intel FPGAs as well. And then there's GPUs from NVIDIA and kind of from AMD and now Intel as well, that they sell into this market. And they all, you know, claim they can do video encoding, and yes, they do it a bit more efficiently than CPUs, but there's some major limitations. To integrate these into your infrastructure, you know, there are some difficulties with regards to the software. You know, you can't just, you know, put these in and expect it to work right away, because your users send you all sorts of you know, video, right? All sorts of format, whether it's vertical or horizontal or different resolutions, different bit rates, different frame rates. And these solutions are typically a little bit more stringent in what they can take. You know, or they take a lot of software work to get them to work for these more complex, or for these like varied workloads and use cases. And so when you look at this, right, like, you look at Xilinx FPGA or an NVIDIA GPU, you might get better throughput than a CPU, but you're still, you have a lot of software work. And then furthermore, when you look at an NVIDIA GPU, right, how much area is dedicated to the video encoding? Less than 10% actually. Most of the area is dedicated for other forms of compute, right? The general purpose, GPU type of, graphics processing or render pipeline or AI and ML. And similar occurs with the FPGA, which is not dedicated to video encoding. It doesn't have any area dedicated specifically for video encoding, but it is a less flexible architecture. And so what that ends up resulting in is, yes, you get some improvements, but you have to give away some in software. And you end up with probably a more efficient infrastructure in some capacities, but you're still not bending this cost curve in an order magnitude, right? You're still spending a ton of money on encoding video. And furthermore, right, like, the availability and cost of each GPU and FPGA is significantly higher than a CPU, right? Intel's average sales price for a CPU is for a data center CPU is somewhere in the $700 range, and AMD's like $1,000. That's last year's data. Whereas NVIDIA, their GPUs are significantly more expensive. Xilinx FPGAs, oh gosh, they're expensive. They're $10,000, right? Is a more reasonable number for a high-end NVIDIA GPU or Xilinx FPGA, right? Not 1,000. So it's you get a lot better cost. You get a lot better throughput per chip, but then you end up paying more per chip, and you have this inflexibility. So there's some problems in that front.
Yeah, definitely. I think eventually when you talk about the best solution to the video industry, you have to consider different factors, and cost per stream or cost per customer. That is extremely important. And to my knowledge, I think the ASIC is the best way to drive the cost down. And that's one thing. Another one is many people talk about the video are so interesting, so attractive, right? But to the industry people, sometimes they also say that the video is the ugly animal. There's so many things that could go wrong, especially when you talk about the live content. It's really need a very focused area. It's a very focused area, and try to improve the quality or try to improve all the features, try to feed to serve the customer better. You have to be that's your first priority. Otherwise, it's just a mediocre or just it's not suitable for the high end of the video industry. That's why I think they need to be a focus, and I didn't see that in the GPU or in the FPGA companies, right? The video is for them is still a small piece, and there's no focus.
Yeah, the lack of focus is important, right? Because the main market for data center GPUs is not video. It's AI and machine learning. The main market for FPGAs is well, there's not really a single main market for FPGAs, but it's certainly not video is anywhere in the in the top of that list, right? Yes, they can use it there, but when you look at where they're adapting their next generation FPGAs for, it's more so for 5G signal processing or AI or networking, right? It's not for video encoding. So these products are going to make compromises, right? They're better than a general purpose CPU, but they're still not changing the cost curve, as we mentioned earlier, in a significant way. That
it's very true. So we use FPGA a lot in our company. We use that for our design. So the FPGA is perfect for the small volume and very unique solutions. You need to quickly adapt, not quickly enough, in fact, but you still have flexibility to adapt the hardware structure and to study the new features and do simulations. That quite good, right? But once you want to have it on scale or try to economically make sense to serve real customers, is not possible, right? It's not served for that purpose at all. Yeah, so Dylan, so you also deep in the trenches of the silicon industry, right? So what insights do you have about different strategies, right? The company are employing for their customer purpose-built silicons?
Yeah, so I mean, in this industry, there are projects, right? I mean, in video encoding, right? Meta is known to have a project working on this. They're not, anywhere near as developed as Google has. With their Argos chip. ByteDance, the owner of TikTok, also has a project in this space. It's unknown, but it's believed they're not, functional with it yet, but we're not quite sure. It's kind of a black box. But they're certainly working on it. And you look around the industry at many other of these major companies that have that aren't necessarily semiconductor companies. I mean, everyone's making their own chips, right? Apple, Google, Amazon, Microsoft is working on some. All of these companies are working on it, but in the video encoding market, only Google has really brought it to bear successfully. And you would think, hey, Amazon, they have some of the best custom silicon in the world, right? They have Graviton, they have the Nitro DPU. Their server infrastructure is really efficient because of these products. But in the video encoding world, they haven't deployed anything that enables them, right? Which is why Twitch still has such stringent limits that make it unattractive to some content creators and had some switch to YouTube, right? Is that, well, they delete your videos after a certain amount of time, right? Amazon can't afford to store them because they're not encoded to a high quality at a small file size, right? You can't stream at a very high resolution because again they can't afford to encode it in real time at a high quality and low cost, whereas YouTube can. And so, Google's been very successful in the market, which has kept them as the leader in most video content. Even today, right? They're gaining some share with versus TikTok. TikTok is actually, if you look at the growth over the last 6 months, they've been effectively flat in terms of watch time. Whereas YouTube Shorts, it's still smaller, but it's growing significantly. And that's why? Because yes, YouTube has a lot of users, but YouTube is also paying their content creators on Shorts, and they're paying them a significant amount more than TikTok is. Why? Because Google has a more efficient infrastructure, right? And it all comes down to these custom built chips that Google's developing, right? Their infrastructure is just more efficient, enabling them to do more with less. And so it's a strategy that's worked really well for them. That maybe is others want to emulate, but they haven't been able to emulate it yet.
Yeah, it's very interesting. So what you say is that the efficiency of their infrastructure also enable their to have a better business model on the upper layer, right?
Yeah, I mean it feeds through, which a lot of people don't realize is that it always feeds through the business will always depend on the infrastructure below it, and you might not realize it, but that this is why TikTok has almost no monetization for their customers, because they have to capture it all. And it's believed that TikTok's not even making much money at all. Despite YouTube being a very profitable enterprise, right? And even YouTube Shorts and Meta's saying, yeah, they've said on earnings calls, short their reels, their Instagram Reels and Facebook Reels, which is their short form video, also doesn't make money yet, which is a significant deal, right? Because Facebook, they're working on an ASIC, on a specific video encoding ASIC, but they don't have it yet today. And so between being able to monetize there, but also just the cost of each video that's uploaded and serving it, they're both at inefficiencies. And so they Meta specifically said they hope to be able to be profitable on Reels next year, but they're not today. And that coincidentally lines up with them saying they're with rumors about their ASIC being ready later this year. Maybe, and that's if the ASIC works properly on their first shot. There's a lot of chance that their ASICs don't work on the first shot, because there's always problems with the semiconductor industry. So one could correlate the fact that their ASICs should be ready later this year, and them saying they'll be profitable next year on Reels, as that being direct evidence that their platform is gated, and their profitability is gated by their lack of semiconductor expertise with their own in-house solution.
Yeah. So I cannot share the customer name yet, but I can say the thing's gonna be a change for this year. So one of the biggest, the short video or social media company, also adopting our solutions, and they already seen they have cut 80% of their operation cost because of this. So things will change, right? And then talking about the big companies, they try to you talk about the potentially they can have more to have ASIC to change their infrastructure. Is that the same for Twitter, right? They just really interested. They didn't have anything for that yet, but since Elon Musk is talking about they want to build everything in one app, right? And talk about 4K live streaming or HDR on the Twitter as well. Do you think that makes sense for them to have that ASIC solution too, right? It seems obviously, right?
So, sorry, I didn't catch the name.
Twitter, right?
Twitter. Yeah, Twitter. So this is an interesting one, right? Like, so if you look back in the history of short form video, right? It wasn't TikTok that made it popular. It was Vine. And then Twitter bought Vine all those years ago, and then they shut it down. Why did they shut it down? Because infrastructure-wise, it's just not profitable to serve video. And now, Elon Musk bought Twitter, and he's, floated the idea that they're going to bring back Vine. And in fact, they've been testing, this tab with short form video sometimes. So, the question is, what are they going to do for hardware infrastructure, right? Like they use a lot of on-premises infrastructure currently for Twitter, but the problem is, that's adapted for serving text and doing that as efficiently as possible. How are they going to move to video, which is a orders of magnitude more video volumes of data, right? Orders of magnitude more volumes. So how are they gonna solve that solution? And it's they just bought the company, and silicon timelines, development timelines take years. They take multiple years to come to fruition, and it ends up even if they wanted to launch a short form video content, they may not be able to do it at any reasonable cost until 3 or 4 years from now, if they develop their own in-house solution. So there needs to be a solution in the public market for them, right? And furthermore, right, like if you think about it, right, does Meta and TikTok, ByteDance, and every other company serving a lot of short form video, Amazon or long form video, right? These three companies, there's a few more in China as well, like Tencent and so on, right? Like these companies all are serving tons of video, and then you add Google as well, and Twitter. That's 5 companies that are already serving tons of video today. If all 5 of them develop their own ASIC solution, that is hundreds of millions of dollars, each, at least $100 million of non-recurring engineering expense at each company, right? So that's $500 million, right? Poof. So this is why semiconductor industry is important, right? Like people always talk about everybody's going to make their own silicon. Yes, they're going to make their own silicon where they have the volume to support it. But what if you don't have the volume on day one? Or you look across the industry, there's 5 players. That's $500 million. Okay, let's divide that across how many units you need. Okay, maybe you only need $100 million. Maybe you only need 1 million units, right? That's okay. That's $100 per unit that you're spending on non-recurring engineering, and that's not even talking about the cost of the chip, the cost of the memory, the cost of implementing it, cost of software. It becomes too much for each individual company to build. So this is why you need a merchant silicon solution, right? That can say, hey, we'll do that development once, and we'll develop it better because we know your needs, and we know your needs, and we know your needs, right? We're uniquely suited to each company's needs, because we communicate with all them. So we're more flexible. We have a more robust software that's more flexible. It can take more forms of video. Maybe today Meta's goal or Twitter's goal, or Tencent's goal is, long form video that's shot only horizontally at certain resolutions. But what if all of a sudden they want to do vertical video that's, at a different resolution, or maybe they want to add a feature that they didn't have before? Well, now they need to go back to the beginning of the silicon timeline and implement it and wait 3 years and then have the silicon come out. And now they can do that efficiently. Otherwise, they'll do it in a very expensive way. So this is where merchant silicon that's more flexible kind of comes in. They can take this $500 million and bring it down to, hey, we're the only ones spending it, and now we can sell 1 million units to you, and you, and that all of a sudden makes more economic sense.
Yeah, that's very good point. So every company they face they have the needs, right? And we already discussed that, but they always need to make the decision make or buy, right? So right now, it seems NETINT a good solution, right? Good candidate for that, but let's figure out. Yeah. So we talk about a lot of what have existing here, and Dylan, so you have seen so many companies, so many technology solutions, right? So from your perspective, what's the next customer silicon that for the video processing from your perspective?
What's the next for this industry? Sorry.
Yeah, what's the next the custom built video ASIC for the video processing?
Well, of course, this is a very loaded question, because of course there's only one company that's making merchant silicon for video ASICs, and that's NETINT, of course. But as far as the custom silicon market, right? Like, okay, fine, I'm uploading video, but and I'm encoding it into a new format. But that's like one use case. But it turns out, if I'm on YouTube, it's great because I can look at the captions. So how am I generating these captions? It's great because I don't just let people upload videos of war or other bad items, right? Like things that you wouldn't want to show kids. You don't just let people upload that stuff, right? They prevent that. And so how do they do that, right? A lot of this is AI algorithms, right? How do you do captioning? Well, you run a voice to you run a model that can convert voice to text, and then you'll run maybe another model that converts that text and adds the correct punctuation and capitalization and so on and so forth. Yeah. And then you'll also to make sure it's safe for everyone, or make sure people aren't uploading illegal content and sharing it on your website, because now you're legally at fault. If they do that, you have to scan every single video. Well, of course, there's so much video, no one can look at it. So again, you're utilizing AI, you're doing detection. Like, hey, are there guns shooting in this video? Are people dying? Is there a lot of blood here? Right? Are there, illegal acts happening? Are there drugs? All these sorts of things. Okay, if those things are happening, we'll review the video further. And maybe we can do a quick pass, immediately as soon as it's uploaded. And if it gets flagged, then we can do a more in-depth review. Maybe it involves humans, or maybe it just involves a larger AI model. But we can do that, later. But every single video needs to be scanned. It needs to be captioned. It needs to be, hey, what content is in the video? Sure, they put search title up. They put a title, but there's a lot of other content, right? Well, what if someone says, they want, whatever the video, they're looking for videos of I don't know, whatever it is, they're looking for a video of it. Maybe it's a machine, maybe it's a tutorial on math, but the title doesn't have that word, but it still shows up in your search. Why? Because when the video is uploaded, they're actually running an algorithm that pulls out metadata. It sees, oh, what are the main topics of the video? Oh, this is about a car, and it's not just about a car, it's about Toyota, and it's about the fuel economy, and it's about the reliability of the car, and blah 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 blah. So now when I search reliable cars, the video that says the review of Toyota Camry now shows up, right? That's the beauty of YouTube and some of these other video platforms, making content discoverable. Or hey, this content pulls out all this metadata. You were watching this video, by the way, why don't we suggest this video to you? Well, how am I generating that metadata about every single video? So these are operations I'm doing on every video that I'm also doing besides video encoding. And do I encode the video and then run them on a CPU, or encode the video and then run them on a GPU? Do I have to, do I have to do multiple passes? It's very costly, right? Especially when I think about memory and networking costs, reading and writing multiple times. The innovations that Google's adding in their next generation Argos, and company, I'm sure some of these other custom silicon projects from Meta and TikTok, ByteDance, sorry, these innovations they're adding some AI processing on the chip. They're adding some general purpose CPUs, just a small amount, so you can do some of these operations at the same time as you're encoding the video. And so you're not reading and writing data multiple times. You're not wasting money on networking. All of these costs are being saved because you're putting them on the video encoding ASIC. So now it's not just a video encoding ASIC. Really, it's a video processing ASIC. And video processing involves a lot more than just encoding. It involves that detection of illegal content. It involves what content can I advertise with this video. Hey, what are some related topics that might work with this video? What's in the video that they didn't say is in the title? All of these sorts of things, captions, all have to also be processed. And that's what the next generation of sort of video processing and encoding ASICs will do.
Wow, amazing. Yeah. So that's a really interesting point as well. So when we have the first generation product, we call the video transcoders. When we have the second generation Quadra products, we rebranded as the BPU, video processing unit. It's really to answer a lot of the questions or the interesting points you raised on that conversation. So we have many features already checked, but it waits the customer to find and how to use that. But there are so many things that we can do for the video part, right? Like how to identify the contents, use the contents, or even to work more with generally with the AI part, right? There's a so broad range of the things we can do now. Yeah.
That's interesting. So what was the feedback from customers, when your first generation, and then as you're designing the second generation, what was the feedback that made you decide, hey, we need to add all these features? Right? Like that's obvious today, but this is a couple of years ago, at least, where you had this input and decided, or a few years ago. So what was the feedback you got from customers that made you drive towards that decision?
Yeah, that's a very good point. So when we have the first generation, in fact, it's a half solution. We have the limited or not compared to CPU is quite efficient, but compared to what's ideal, the VPU is still have some room to improve, right? So the customer feedback normally on certain areas. One is they want even higher density, higher performance. So, and also they want new codec. So we added the AB1. And to answer the performance, we increased the peak performance from 4K 60 to 8K 60 and added the new codec. And also they want more scaling feature because they have like the ABR ladder, they need one resolution in and a split or the scale down to different resolutions, right? That we add very powerful scalers. And also they want to understand the content in the video, just like you said, they want to know what happens in video and to fully utilize the value of the video and also to prevent some of the issues, right, on the fly. So we added the AI capability into the Quadra. So and also there are some other parts we are not fully utilized yet, like the audio processing as well. And also we have relatively still powerful 2D engine that can, and the DSP can do a lot of programming as well to have more flexibility on the fly to add new features and serve for the new requirements. That's a feedback we got from first generation and put to the second generation. In fact, we are also in the feasibility phase or third generation, we are also open to ideas and suggestions. That's why I'm also asking you, is there any something that your customer are expecting to see in the future, right? So we can continuously improve that, and video is a really focused area.
Yeah, that's super interesting. So your first generation solution, yes, it encoded video, but it was very stringent in what it could encode, right? only certain target resolutions, which was fine for, certain, at that stage. But as you went forward to the second generation, customers demanded, yes, this is an ASIC, but give us flexibility. And furthermore, you needed to add some of these functions like, a little bit of AI processing, so you could caption a video, or you could detect if it's illegal content, or these sorts of things. And so you added that with your second generation, and you're improving that in your third. You're making the chip, the chip much more flexible, right? You ingest one video, you can output it in multiple formats. You can ingest it in almost any format and put it out in almost any format. You added support for AV1, which is still not deployed heavily yet, but it's going to be deployed heavily, right? I mean, everyone's adopting it. Netflix has said they're going to adopt it. I believe YouTube has said they're going to adopt it. There's a lot of firms that have said they're going to adopt AV1. There's AV1 support in a lot of devices, right? Every new Intel CPU, every new AMD CPU. I just got a new Qualcomm phone. They all have support for AV1 decode, right? But encoding is very much, even where there is encoding support on the newest, NVIDIA GPUs or Intel GPUs, it is very limited. And in terms of what level it can support and how much throughput it is, because this is such an intensive operation. And the main purpose of that chip is not encoding. So you've added support for that as well, and you've raised the throughput and resolutions and flexibility. Can you talk about like the software implementation a bit of this, right? What are some pain points? Because I've heard a lot of pain points in the industry about implementing ASICs into a process. Implementing ASICs into your workflows, into a distributed system where I'm getting video from everywhere and I'm exporting video everywhere, right? Can you talk a bit about that?
Oh, that's a very interesting topic and important topic. This can be extended for more than a few hours, but I'm very happy to talk about that. So in fact, there are different scales or different layers of the issue talking about the software solution, a total solution for the video, or generally for the ASIC solutions. So the first, and most people didn't notice, is how it can work with the host system or different operation system, different kernels. It's a really painful process for ASIC, or not only ASIC, for any hardware to work with different operating system. They keep upgrading, right? The kernel always has different versions. When you spend hundreds of man-months to develop a driver, and there's a upgrade to their different version, you need to redo that again, right? That's why we start from beginning. We are designing a totally new approach. We call it the computational storage structure. So or VPU is on top of the existing NVMe driver. So whatever the operation system or kernels, as long as they support NVMe SSD, they can support us. And to adapting to operation system or kernel version to a new one, to us is only a few days work, and mainly is for the testing. We want to make sure everything is right for that. And we have a server farm of a few hundred servers try to run the 24/7 to test, to make sure it's mature for that system. But for us, it's really easy to do, right? And we can even plug and play to the system. They can recognize the cards and start to use it, right? That's the very fundamental layer that is different compared to all the other solutions, which is much advanced. And
that's interesting. So everyone uses NVMe server SSDs, right? NVMe being the protocol for solid state drives. That's pretty much the dominant one, right? For the last at least 5 to 10 years, right? It's been the dominant protocol for SSDs. And so you're sort of piggybacking off of that infrastructure, right? Saying, hey, our ASIC, we're just an NVMe device, right? You write to us, and then you read from us. And it just so happens when you write to us, you send us the unencoded video or video that's poorly encoded, and we output the properly encoded video. And so, almost every, every x86 and even ARM CPU supports NVMe, right? My laptop has NVMe. Actually, iPhones, people don't know this, the iPhone NAND is actually communicated with the SoC in over NVMe. Like, of course, you're not going to get into an iPhone, but NVMe is everywhere. So it's an industry standard that you support, and it's in every host system. So that's really cool. Then it makes the ease of use a lot better.
Yeah. So we support x86. We support ARM architected servers. We also support IBM Power 10, Power 9 series of the CPUs as well. We support the Linux, Windows, Mac, and also Android system. So whatever you have, as long as you support SSD, NVMe SSD, we can support it, right? So that's easy. And beyond the fundamental layer, on the software layer, we is working with the open source system like the FFMPEG and the GStreamer, and to fully seamlessly integrate to that. And in fact, most customers are using these two framework for their video flows. So whatever they have built on software using FFMPEG or GStreamer or similar solutions, they can easily to work with us. It's just to recompile the FFMPEG with our library. That's it. When you run the code, you just change the pointer from software to us. Finish. Then you can keep your current workflow as it is. That's so easy. Of course, there are some of the challenges that we can see with the FFMPEG. Is the FFMPEG was designed for the single thread. It's not for the very extensive, massive in parallel processing. So for the big guys like the top cloud companies, someone you already mentioned, they will skip the FFMPEG layer but call our API directly. Then they can truly utilize the whole potential of the hardware. But that's a advanced layer of how to use that. Yeah.
So FFmpeg is sort of the industry standard, right? Like if I wanted to encode, I use FFmpeg on my Windows, right? Like if I wanted to encode some video that I had. So this is not only for like an application like the cloud, right? Like this could also proliferate down to some security applications where I have hundreds of cameras or dozens of cameras in a building. Instead of having to encode them on so many CPUs, I could use maybe one or just two NETINT ASICs, and I could encode all of those videos at once, and it would work on even a Windows system. That's so you don't have to upgrade a lot of your infrastructure. You plug in an ASIC, and again, almost every CPU, even going back, even desktop CPUs for a decade supported NVMe. So it's not a big difficulty to get this up and running.
Yes, yeah, exactly. That's also one of the use case that our customers start to using, and they have whatever they have, the cameras, old style or the new ones, they can all accumulate the video streams to the server with our cards. They can transcode that and also analysis them in the same time, right? Then they can compress it and either store that on local or stream out to the cloud data center for further analysis or for the first responders to watch the video online. That's a very typical use case.
Yeah, so your second generation has some AI processing, right? And
yes.
And the third generation has even more. So as you mentioned, you could take the video from the cameras, you could encode it, or you could just run inference and say, hey, there's somebody on the screen, or hey, the screen is changing. Okay, we'll store this video, but we won't store the rest of it. Or hey, there's somebody that looks suspicious on the screen. We'll send this to we'll alert the authorities automatically. Or we'll alert our reviewer automatically, rather than having to wait and saying, oh no, what was stolen? Oh well, we can look back at the video. No, we can preempt this.
Yeah, exactly. Yeah. And there are some, in fact, some of the features that people didn't have chance to use or didn't realize the value of that yet. Like we talk about the NVMe protocol, right? But by designing that way, we also can have a box of our cards just connect to the host through the NVMe over Fabric. That is a pool of the results can be shared by not only one host, but the whole data center, right? They can access the VPU just like local results. By doing that, they can further improve the efficiency of the resource utilization. So that's a pretty big thing, I say, for the hyperscalers. And that, I think that be going to very valuable to the customer, especially you have the video encoding, decoding part there. You also have AI part also shared with the whole data center scale. Right? That is just, I think it's a hidden jewelry that nobody really have chance to use yet.
Yeah, that's interesting. So you know, the flexibility is there. There's some, you know, unique use cases, especially on like retail and you know, manufacturing, you know, where you're going to record a lot of video and you want to take actions based on what's in the video.
Yeah.
So, you know, you look at smart cities and, you know, it's, you know, we talk a lot about the content as a consumer earlier in the show, right? You know, what happens with YouTube, what happens with, you know, Instagram Reels and TikTok and all of these, you know, forms of Twitch, you know, video streaming and all these sorts of things. But, you know, we didn't talk about, like, you know, this has use cases beyond that in the smart city and in the manufacturing and in industrial. You know, every traffic light could potentially in the future have cameras on it, right? And you can instead of encoding, you know, and you could stream it all and have maybe a single encoding chip serve multiple, you know, a whole store or a whole block. Yeah.
It's all about the efficiency and the best way to process the content. Yeah, and then there are in fact some other applications that the normal people may not notice, like the virtual desktop infrastructure. Right? More and more people not using their own local machine; they're using the servers a few miles away or hundreds of miles away. Right? That's all. It's video streamed to your device. You can work from the hotel, from home, or whatever place, with the highest performance of the server on the data center. What you need is just a mouse, a keypad, and also a bigger display. Yeah. Okay. Yeah. I think the time is over. So, is there any questions, or we just we're open to questions? Oh, no questions. That's good. Okay. Okay, then thank you, Dylan. It was great to have you here and also hear your valuable insights about the industry. Thank you very much.
Thank you as well, Alex. Look forward to chatting with you again.
Yeah, we do.
Bye.
Thank you. Bye-bye.